Hello everyone. So today we'll be looking at the unit circle and trigonometric ratios. Now the unit circle is a really special type of circle that has some really interesting properties and something you'll see a lot of if you go further with maths. Now if you look at it just simply, it's not that difficult a concept. The unit circle is a circle, and the reason it's called a unit circle is because its radius is one unit. Okay, so it's a circle with a radius of 1 unit, and the center of the circle is at 0, 0. Okay, so that's just here, 0, 0. Okay, now because of these properties, has some really interesting features. Now, firstly, we'll have a look at the intercepts. So if it has a radius of 1, it's going to touch the x-axis at 1 and 0. Okay, the radius is going to expand there to 1 and 0, and -1 and 0, because this radius can move all the way around the circle. And same as the y, it's going to go up to 0, 1, and down to 0, -1. All right, and in between, we'll see how we can work out those. So just down the bottom, I've written the unit circle is a circle with a center 0, 0. Okay, so the origin is the center, and it has a radius of 1 unit. Now, another property of the unit circle is the fact that if you take the x-coordinate of a point on the circle plus the y-coordinate, both of them squared, it always equals 1. Now, we can have a look at that for the couple of points we've got on here. So we've got, let's start with this one. So our x is -1 and our y is 0. So -1 squared plus 0 squared equals, should equal 1, but let's work that out. -1 times -1 is +1 plus 0. 1 plus 0 equals 1. All right, so we've shown that these two things squared equal 1. If I put in this point here, 0 squared plus 1 squared equals 0 plus 1 equals 1 again. And this is going to happen for all of these points that I've shown and every single point in between. And we'll have a look at that, what those points are, how we work those out in a moment. Okay, so you can see from here that we can also relate this really strongly to angles all around the circle. If we take any point on the circle, we can always find an angle. Now, there's a couple of rules with the angles. The first one is we always measure the angle from the positive x-axis. Now, what that means is if we have a point on the circle, let's say it is here, okay, and I drew the radius out to that point, I would measure the angle to this, not from the y-axis, not from the negative x-axis, but from here, from the positive x-axis. Now, the angle that I give, the next point is if I measure anti-clockwise, like I have, I'm going to give my angle as a positive number. So this one is just a bit past 90. It's maybe plus 110 degrees. So I'd say plus 110 degrees. Okay. Now, if I'm measuring the other way, if I measure clockwise from here around, I have to use a negative number. Okay, so 360 degrees in a circle, I've done at 110. So that means this angle here is -250 degrees. Now, just once again, the reason for that is because 110 plus 250 equals 360 degrees, and that's what makes up a circle. Okay, so if we go anti-clockwise, positive, clockwise, negative, we always measure from the x-axis here. Okay, so let's have a look at the next point, and this is going to delve back a little bit into what we already know about trigonometry. Now, if we take the cosine of theta, so right here we've got a unit circle, we've got our radius is 1, the distance we go along the x-axis is a, so that coordinates to this coordinate a, and the height is b, which is the y coordinate here. So our cosine theta, we know that is the SOHCAHTOA, the adjacent over the hypotenuse. Okay, if we've got an angle here, our adjacent is A and our hypotenuse is 1. So that equals A divided by 1, which is the same thing as A. Alright? And if we take our sine of theta, it equals the SOH opposite over hypotenuse, which equals our opposite is B over 1, which just equals B. And if we take our tan theta, it equals opposite over adjacent, SOHCAHTOA, which is our opposite is B, B, and our adjacent is A. We can't simplify that any further, so that's B over A. Ignore this part. And these have some really interesting properties. So what this means is, this is our, if we have a look at our P value, this is the X coordinate. Our B is our Y coordinate. Okay, and we have a look at B divided by A. That also has an important concept. Now, what that concept is B is our Y coordinate, which we could also call our rise. And our A is our X, we could call that our run. Now, rise over run, that's the informal term for the slope or the gradient. So if we want to find the gradient or the slope of this line, we can find the tangent of the angle, and that will just give it to us straight away. So what this means is, instead of writing the point PAB, we could write the point P, and the X coordinate is cosine theta, the Y coordinate is sine theta. So we could work this out just by being given the angle. Okay, and just again, the tangent of our unit circle, the tangent of the radius, is the opposite, B, over the adjacent A, which we just confirmed was the rise over run or the gradient. Okay, so that's another really important concept. So we've got tan, cosine, and theta as really important concepts. Okay, so let's have a look at an example now, and what we want to do is find the coordinates for the following angles on the unit circle. So A is 63 degrees, and what I'm going to do is just mark that on there. So 63, it'll be just beyond halfway, so it'll be about here, and let's call that A. Okay, and we can mark that 63. Remember, we measure from the x-axis around, so we could call that 63 degrees. Okay, so we want to find that one, and we want to find B, which is negative 135. So negative 135 would be over here. Remember, we go negative, we go this way. Negative 135 degrees. Ooh. Call that degrees. Okay, and we'll call that B. So the coordinates for A are, remember from our previous slide, cosine of our angle, and then sine of our angle for our Y coordinate. So what we need to do is just put this into our calculator. So the coordinates of A, it equals cosine of 63 degrees and sine of 63. Ooh. What am I doing? Sine of 63 degrees. Okay, and if you put these into your calculator, you get that the point A has coordinates 0.454, and that's for the x coordinate, and the y coordinate is 0.891. Okay, so that's the coordinates of this point here. Now, the way we can check this is legitimate is if we take the x squared plus the y squared, it should equal 1. Now, I've rounded this, so it's not going to be exactly 1, but it should be approximately. And I want you to put this in your calculator now. Put the x coordinate squared and plus the y coordinate squared, and see if you get an answer equal to 1. All right. So now let's have a look at Part B, again, we want to take the cosine of our angle, negative 135, and the sine of our angle, sine negative 135. Okay, I didn't mention before, but we need to make sure this is our calculator when we're doing this is in degrees, not radians. Okay, these angles are measured in degrees. If it was given in radians, you need to put it in radians, but at the moment it's in degrees, so that's what we are dealing with. So now we just put this in our calculator, remembering to put the negative in, and what you get is the first one is negative 0.707, and the y coordinate is negative 0.707 as well. Okay, this actually translates into negative the square root of 2 and negative the square root of 2, and we'll see why this is really important later on in the course. So excellent. Again, if you square both of these numbers, you are going to get 1 over root 2. Trying to get to the next point quickly. So again, if you square both of the numbers, if I square the x term, 1 over root 2, negative 1 over root 2 squared, plus negative 1 over root 2 squared. If I square those, I get 1 over 2 plus 1 over 2 equals 1. So again, it checks out. All right, and that's always going to be the case for every point. So the coordinate of B is these points here. Okay, so last example, I just want to find the gradient of the unit circle for the points in the previous example. So we know the gradient is the tangent of the angle. So if we put in the tangent of 63, that'll give us the gradient. And if you put this into your calculator, again, making sure you're in degrees, you get a gradient of 1.96. Okay, and for B, if you put this in, you get a gradient of 1. Now the reason for that is 135 degrees means it's 45 degrees on this side, 45 degrees on this side. So our rise equals our run. If the rise equals the run, we're going to get the same number divided by the same number, and we get a value of 1. Okay, so we'll do some questions now, but hopefully we can move from here. Thank you.